Okay, so in section 9.6, you've already talked about doing the numerical equations to find the value of x. And now we're going to work on 3 word problems. And so feel free to rewind this, fast forward it if you've already learned this from me. But this is kind of some like a thinking question or 3. Okay, and so I'll do my best to kind of lay out the framework. I think the big thing on this first one is we are trying to make a solution. And if you're trying to make a solution, you know that there's the volume, the overall volume, and then the chemical or the alcohol or whatever you're going to put in it that is dissolved within the overall volume, and that's going to be a certain percentage strong. Okay, and so if you read the question, you'll notice that it says you are looking to make a 70% isopropyl alcohol solution. That's our goal, okay? 70% means 70 grams of it, or 70 whatever of the overall volume is going to be alcohol compared to 100%. So 30% will be something else. 70% will be the alcohol. And so this is our goal, and we're going to put that on the right. 70 out of 100 needs to be the solution, okay? So it's going to be a pretty strong solution, okay? Isopropyl alcohol. Maybe they're cleaning something. I'm not sure what's going on here. And so suppose that you are adding a 15% solution. So you're starting with a 50% solution of isopropyl alcohol, okay? And you're adding that to another solution that you have 200 milliliters of 91%. So essentially, the green one I've got here, the 200 milliliters, that is 91% isopropyl alcohol, is too strong. So you're going to dilute it to get to the appropriate concentration. Okay, so you're going to add those two, the one that's too strong, the one that is too weak, and you're going to add those together so that you can have a 70% solution. Okay, and so you don't just want to make it 70%. They also say, yeah, that's our goal actually. Okay, and so this is going to be how much is going to be the concentrate alcohol out of the total. Okay, 70% means 70% of the total, 100% is going to be alcohol. Okay, and so we're going to have a fraction on the left side. Of course, this is the chapter of fractions, so that's kind of what we've got going on. And it says we're starting with 200 milliliters of 91% alcohol. Okay, and so on the denominator, that's going to be how much total we have. We have 200 milliliters of the original substance, okay, and we're going to add to it a certain number of milliliters. So that's a really good place to start. And the other thing we're going to do is, you know, within each of those solutions, a certain percent of that volume is actually straight alcohol. Okay, and so of the original one, the green one, okay, we have 200 milliliters, that's 91% alcohol. So we do 0.91 times 200. Okay, and so if there's 200 milliliters of it, you know, we could figure out, well, how much of that is actually alcohol. And so we can find that product. And so I'm going to take 0.91 times 200, and we get 182. Okay, so that's how many milliliters are actually alcohol. And if you did the fraction and did 182 out of 200, well, yeah, 91% of that is alcohol out of the 200 milliliters they have. And then we're going to add to that, we've got 50% solution. Again, we're trying to dilute it to get to 70%. And of the pink liquid, half of it is going to be alcohol and half is going to be just water. So we're going to say 50% of whatever we add of that diluted solution is going to be alcohol out of the total solution X. So this is going to be our setup. How much alcohol is in the numerator? How much total volume is on the denominator? And so our hope is to say, how much X of that diluted solution do we have to add? That will, yes, it'll increase the overall volume. That's why there's an X in the denominator, but it'll also, there will be more alcohol added, but only at a 50% proof. Okay, and so we've got to figure out, well, what X is the appropriate amount so you don't get overly diluted, but you get it exactly where you want it to be. And so when we look to solve this, because we just have a fraction on each side of the equation, we can cross multiply. Okay, so that's something that we can do at this point. So what I would suggest is you just have a fraction equaling a fraction. And we didn't see that a whole lot yesterday, but that's absolutely something we could do, is say, take this numerator here and set it, times it by this denominator down here. We're going to find that cross product and set it equal to the cross product of this 70 times this denominator right here. Okay, so we're going to take 70 times that, equaling, okay, the product, these two guys together, times by 100. Okay, so find the cross product of each. I was hoping that it wouldn't delete it too much, but it looks pretty good. So we're going to take 100. Oops, I don't want to highlight. I want 100, and I want to multiply it by 182 plus 0.50x. And we're going to set that equal to, I guess we're going to just skip this over. Set that equal to the blue cross product, which would be 70 times 200 plus x. Okay, again, the numerator is how much alcohol, and the denominator is the total volume. Okay, so if our goal is to have 70 out of 100 alcohol, then we're going to take our 182 milliliters of alcohol plus 50% of whatever we add, and then that should be 70% over the total, which is 200 milliliters total, plus an additional amount of milliliters you're dumping in to help dilute it. So if we cross multiply and we solve this, we are going to get, let's see if I've got some math here, 18200 plus let's see, 0.5, so it'd be 50x is equal to and if we go to solve this, we're going to subtract the x's to get to the same side. You get 20x on this side if you minus 50x from both sides. And on the other hand side, we're going to take, get my calculator out. If I take 182 minus 140, we're going to get 4,200. Divide both sides by 20. And you get 210. So that means X represents, I need to erase that, I'm not sure. If X represents how much more you add of the 50 milliliter solution, then of 50% isopropyl. Okay, so you're going to add 210 milliliters of that diluted form, and that will dilute our 91% strong solution down to 70. If I add 200, if I add more than that, it'll be too diluted. If I add less than that, it won't be at 70%. So this is how you set up. I want you to practice this on your homework. The next one is about distance, rate, and time. And I think this is something that we've spoken of before, but I don't know that it's something that you think about on the regular. DIRT means distance you travel is equal to the rate you go for the time you go it. Okay, distance equals rate times time. And if I ask you to use that formula, you would solve it for any of these three letters. If I want the total distance, I could times the rate times the time. If I want the rate, I could divide both sides by t. And the rate you go is equal to the distance you went for the time, which makes sense. When you measure your rate you go, it's in miles per hour. Okay, so absolutely, you could solve that equation for rate. What we're going to do in this question, that's going to be the most common way to talk about it, would be First of all, this is a good thing. If I ask you to express the rate, you would do distance divided by time. That's going to be a good thing to hold on to. The problem we are going to do today, and I believe the same one that's going to be your homework, is going to be time. If I want to solve this for time, I would divide both sides by r. So the time you have traveled is equal to the distance divided by rate. Okay, and so, and you can try it. And you could, do an experiment of like, hey, if I went 500 miles and the rate I went, was 80, you can divide those and it will tell you how much time it would take for you to go that many miles. So the time you go is equal to the distance you want to go divided by the rate. Okay, and so that's going to be a really good formula for today. So let's put a big old flag around here. But you start with dirt and solve for keep it in terms of D, or solve for R, solve for T, depending which one you want to express. This one says, these bats have an average flight speed of 25 miles per hour. Okay, so today, as we write this, or like if you read it, it says, okay, these bats have a speed of 25 miles per hour. And suppose it takes a bat's 5 hours to fly to 121.8 miles round trip. Assume they flew at a constant speed, determine the speed of the wind. You're like, okay, who talked about the wind? Well, the truth is they're flying with the wind and they're flying against the wind on one of their trips, okay, one each way. And so if you think about if you run track, if you're running into the wind, it slows you down. If you're running with the wind, that it speeds you up. And so it takes your velocity and increases it if you have the speed of the wind to kind of push you as well. Okay, so runners, etc., definitely notice the wind when you're trying to run because it absolutely slows you down or speeds you up, depending if it's with you or against you. So you're like, there's a lot going. Yes, but this is something you need to know how to do. Okay. What is the total they're talking about? And the total is, and this is the same, you'll see a similar problem like this. The similar thing is it takes 5 hours. That's your total. Okay. And so we're going to say 5 hours. Okay. Equals. Okay. So this is time. And so the thing is, they don't tell you any other times. However, they do tell you the distance and the rate they went for both trips. Okay. So the thing is, if you know that time is equal to distance over rate, well, the distance they went was 121.8 miles round trip. Well, round trip means they went half on the way there and half on the way back. So divided by 2, and this is, again, you'll have to duplicate this. You're going to say it took 5 hours total. And so half of 121.8 is a lovely 60.9. Okay, that's a distance, and that's miles. And this is 60.9 each way. Okay. And so again, time is equal to the distance you went divided by the rate that you went. Okay. So again, if you had to go 60 miles and you went a mile per hour, that is not very fast. Okay. It's going to take you 60 hours to do it. So you're divided by your rate of speed. So normally a bat can go 25. Okay. 25. But with the wind, their velocity is increased. And against the wind, okay, their velocity is decreased by the rate of the wind. Okay, so it's really kind of an abstract situation to be like, how am I setting this up? You're saying we're accounting for the 5 hours. Well, some was on the way there and some was on the way back. And we're going to just kind of say one way he had the wind pushing him for his speed, and one way he had it going against him. Okay, so it decreased his velocity by the velocity of the wind. So distance over time. So you're going to have to know dirt, and you're going to have to be able to say, okay, my goal is time. Can I put distance divided by rate to express the 2 directions that they went and how long it took them to go each way? And so absolutely, this was something you need to duplicate. So how do you solve this? Well, we're trying to solve an equation. We want to find the value of the wind, the common denominator, because this has a denominator of 1, excuse me, would be 25 plus W, and 25 minus W. Pardon. It's a yawn. Here we go. And so if we multiply all three terms by those two factors, we're going to make an equation that still has variables in it, but it won't also have fractions. And so if we times the last term by it, okay, you notice that the 25 minus W will cancel out with the 25 minus W, and you're going to be left with 60.9 times 25 plus W. If you multiply those same two factors, 25 plus W and 25 minus W by the second term, the 25 plus W's will cancel out, and you're left with 60.9 times 25 minus W, okay? And on the left side of the equation, notice all they have is 5. Okay, well, notice these are conjugates. So you're welcome to take 5 by both of them. But if you recall, 25 plus W times 25 minus W is going to be 625 minus W squared. If you FOILed it out, you would get, it's the difference of two squares. 25 squared is 625. You get plus 25W minus 25W minus W squared. So I'm just going to take 5 by that. And now if we distribute and solve, we're going to get our answer. And so, let's see what work I've got here. This is 625. Okay, so you get 3125. The numbers are kind of big and obnoxious, okay? So you want to be careful of signs. You want to use your calculator. You want to write carefully so you don't confuse yourself as you're going. This is actually a 5. I did not read my own handwriting. Okay. And then plus 60.9 W. Okay. Now, good news is some stuff will cancel out. So negative 60.9 W cancels out with positive plusing 60.9 W. Those eliminate each other. And then it is a quadratic, but if you notice, there's only a W squared. There's not also a W. So we're not even going to have to factor. Hallelujah. Okay. So I told you anytime you have a quadratic, it'll factor. The exception would be if it is just a square root property. And that would be in this case. And I hope you forgive me for telling you that tale, but it's a much kinder gift than actually where we're at. So you're going to get negative 5W squared. If you subtract a 3125 from the right-hand side, you're going to end up with negative 80. Divide both sides by 5. You get W squared is equal to 16. W is equal to plus or minus 4. So the wind speed, okay, is 4. And it looks like we're talking about miles per hour. Okay, so that means that if it's going with the wind, the bat is going 29 miles per hour. If it's going against the wind, the bat is going 21 miles per hour. And so we're looking for basically about what wind speed helps this problem make sense, that given that he has to go a total of 121.8 miles, half of it's with the wind, half of it's against the wind, how strong is the wind going if he normally can go 25 miles per hour himself? So absolutely want to practice this question as well. The third question is a word problem about planting. Okay, and so if you've noticed in our homework, there have been things about this. And I think the big thing on this one is the distance you can go is equal to the rate you go for the time you go it. Okay, so distance equals rate times time. And so if distance equals rate times time, if you want to know someone's rate, you would say their rate is equal to the distance they go for divided by how long it takes them to do that. So in this case, they want to say one job for the time it takes. Okay, and so we've got this 24-row planter, and it takes 10 hours for this planter to do a whole field. Okay, so it's a pretty good size planter. Another planter, okay, is a 16-row planter. Okay. And so the thing is this, they don't give us the rate at which it would take a 16-row planter to do the whole field. It says if they're working together, it takes 6 hours if you also employ this other one. Okay. And they're like, well, how fast is the 16-row planter? Well, if you think about it, unless it's like a really fast one, probably it's a little longer than 10 hours because a planter that can do 24 rows takes 10 hours to do the whole thing. If they work together, they can take 6 hours. And then the question is, what if I just only use the 16-row planter? Okay, so I would think that would take longer than if I use the 24-row planter because it can't do as many rows per pass. Okay, so let's check and see what we can do about this one. So the thing is, sometimes they'll say for one planter takes one job every 10 hours. Okay, one job takes 10 hours. Okay. And then they'll say, oh, the second, if the second machine takes 6 hours, how long will it take to do the whole thing? And we could solve that. Well, this one says, the second planter, we don't know, it does a one job in who knows how long it takes. Okay, we don't know the rate of speed that the 16-row planter can do by itself. Okay, how long will it take? I don't know. Okay, but we do know that we add their machine power together, and together the one job takes just 6 hours. Okay, so together that takes one job, takes 6 hours. Okay, there are different ways to set this up. Sometimes they'll say, how long would it take to do just one job? And you set equal to 1. This is how we're going to use this this equation this year. Okay, one job takes 10 hours. The other machine takes, we don't know how many, but together, once you plus those two rates together, one job takes 6 hours. And so we're going to solve this equation. A common denominator could be 60x. We could have gone with 30x, but if you just multiply the two factors together, you would get 60x. So you can choose what do you want to use for a common denominator. I guess we can go 30x. Okay, 30x, because that would be a good common denominator. And if you did that, you would get, if you multiplied by the last one, you would get 5x. If you multiplied by the second to last one, you would get 30. And if you multiplied by this one, you would get 3x. If you solve it, you get 30 equals 2x. So x is equal to 15 hours. So it takes the 16-row planter 15 hours to plant the field alone. Which makes sense, okay? If you've got two planters that can work together and get it done 6, and the bigger planter takes 10 hours, well, it's gonna. If you got a smaller planter, it's gonna take longer. All right. Well, these are the 3 word problems you're gonna need to know how to do.